Good morning. Today we are going to see about the linear data structure. In linear data structure we have many types. In that we are going to see about the list. List is the most common data structure which is used. The most important thing is that we can call it as a ordered list. That is, we are going to store the elements in a alphabetical order, or arranging the elements or storing the elements in a sequential order. We can insert or delete the element wherever we want. This is the special thing about, or the insertion as well as the deletion is a simpler in list. How to implement the list is, we are what is the next we are going to see about the features of the list. What is all the important feature about the list is that all the element of the list having the same data type. The list is to be empty if the list is the list having the number of elements means all the elements are in the stored in the sequential way or ordered in an ordered way. We are going to implement in a list in an abstract data type as an abstract data type. Okay, what are the list operation has to be performed over here? We can insert or delete, or if you want to find or a search or any element in the list is possible over here. If you want to insert that elements means the list sizes grow. If you want to delete the element, if you want to delete a particular element in the list sizes shrink. So that you are mentioning the grow and shrink in sizes. As well as we can easily find out the previous as well as the next element in the list. The next, what is the thing we are going to implement the list in a easiest way is the array. We are choosing an array as a way for implementing a list. What is the special thing about list array? Array is a collection of elements of the same type, which is used for storing the elements in a sequential way or in an ordered way. The element that is the sequential way or in an ordered way means the elements which is stored in the memory is in a contiguous way. The simplest thing, elements of the list has to be stored in a memory in a contiguous way. This is the special thing about array. And another thing about array is the array is used for static memory allocation. One, what is the if there is any other way for implementing the list? Yes, we have another way for implementing the list is the linked list. That by using a linked list, we are dynamically allocating the memory for each and every element in the list. How to represent the linked list means we are going to represent the elements or an object in a list using the term called node. Node, in the sense, we have node is divided into two parts. One part is for storing the data element or element. Second part is for storing the address of the next node or pointing the address of the next element in the list. Next node or next element in the list. This is the simple structure of the linked list. This is the 2 is the node. 2 is a node, 6 is a node, 4 is a node, 7 is a node. Then 2 is having a two part. That is, one is part data for storing the elements. Second part is for storing the next part. We can call it as next part for storing the address of the next. The node 2 having the address of node 4, 4 having the address of 6, node 7 doesn't have any elements to point out it. So what is the next part? What is the next part of 7? Obviously, it contains the null value. Okay, we can have many types of the linked list. One is a singly linked list, doubly, singly circularly linked list, and doubly circularly linked list. Singly linked list, we have there is no confusion in that. We have a node, only the two part is over there. One is the data part, another one is the next part, that is the pointer to the next field. Another important thing for all the linked list is that we have to maintain a head pointer or a start pointer for pointing the starting element of the linked list. Starting element or starting node in the linked list. This is what sometimes we can refer the term head, sometimes we can refer the term start. Don't confuse with that. The head, which is used for pointing the starting node or starting element in the linked list. This is the header. This is for the implementation of the singly linked list. What is the last element in the linked list which contains, if the last element doesn't have any points to any elements to link with that or point to that, means we can store the null in that field. We can easily understand the how the insertion has been happened and the deletion. Insertion means if you want to insert the element 6 into that field, means you can simply replacing the address of node 6 to the in the place of node 1 next part. You are simply replacing address of node 6 to the address of the or next field of the node 1. This is what happens. One, how the deletion has been happen over here. In deletion, we are just replacing the value. Just replacing the value. What is the value we are going to replacing? That means we are. If you want to note, in first diagram we are showing the 3 nodes. In second one, if you want to delete the element. 10 means delete the node 10 means what we are going to do, you just replace the address of node 12 to the in the place of 23 next part. You just replace the address with the next pointing node. This is the simple step we are going to perform over here. Then how the memory has been deallocated, means we are allocating memory in a dynamic way. So we need not worry about that. We can deallocate the memory using the free operation. This is the free of that particular node, particular variable name. This is the simple way of representing the linked list or node of the linked list. We have a two part, one is data part and the one is the next part. Then we are going to see about the doubly linked list. We have a 2 pointers over here. This is the simple diagram. We have a 2 pointers over here. One pointer is pointing to the previous node. Another pointer is pointing to the next node. That is the preceding node, successor node. Or a current node or tailor node. We can say like that. Preceding node or previous node or forward link and backward link. One pointer which is pointing with the backward node in the list, one pointer is pointing to the forward node in the list. Then next one is the singly circular linked list. What is about singly circular linked list? Which is having the last node is pointing to the first node of the list. Last node, that is one is the last node which is pointing to the first node. What is the first node? That is the node 10. Node 10 is the first node. Address of the node 10 which is stored in the header node, so it is pointing to the header node. This is the singly circular linked list. What is about doubly circular linked list? There we have a two-way connection. That is the last node is pointing to the first node and first node is pointing to the last node. This is the doubly circular linked list. Okay, thank you.